Okay, first in this video we're going to look at the effects of force, some of the different types of force, and also what forces we have around us. When we look at this picture then, we can see that the forces are having an effect on the motion of these objects on these cars. But what do I mean about the motion? There's different ways in which the motion, the movement of an object can be altered. Firstly, the shape of it can be altered. So in this instance, the car's crumple zones are flattening, the gas is flying everywhere, so the shape of the cars are altering. We've then got the actual direction of the cars. They'll probably drive in straight at each other at the start, but then they get tossed to the side slightly and thrown up in the air. They're no longer going in the same direction. The third factor that's affected is speed. These vehicles have gone from travelling very fast at each other to virtually on stop. So their speed has been altered by the force. So the three factors that are affected by force are shape, direction and speed. So let's have a look at some examples of forces. You've obviously heard of weight, pulling an object, acting on an object because of its size. We've also got friction then, a force when two objects rub against each other, usually slowing things down because of the two surfaces rubbing. Electric forces are created by the movement of particles called electrons, and of course we use electricity around the house, but it's a force as well as a form of energy. Magnetic force is then created by magnets, not necessarily the little types that we might have played with as children, but also the planets have their own magnetic field, which the force of which acts on different objects. You've got upthrust, which a floating object has a force that pushes it upwards. Otherwise, if there was no force pushing it upwards, it would simply sink. And that force is called upthrust. We've got drag, which pulls objects backwards, different to friction, but when a car moves along, it'll have drag that tries to move it backwards. Thrust, and we know that vehicles often create thrust to push it forward, or a rocket maybe uses the fuel to create the thrust force to fire it up into the air. And then forces such as tension, which you find in ropes and springs that are being stretched. And one of the most unusual ones is reaction force, which a lovely example of that is when gravity forces objects downwards. Believe it or not, the surface of the earth, when you're touching it, is pushing back, and that's called a reaction force. You may not, it's hard to understand the concept that the earth is pushing you, but it's due to the vast size of the earth that the force is spread out amongst the size, so it has very little effect on you, whereas the gravitational force is spread out amongst your mass. Because you're so small, it has a much bigger effect on you. And if you don't believe in the idea of reaction force, why do you feel the bottom of your feet? It's because the earth is essentially pushing up against you, creating a reaction force. Now we've got two different main types of forces, vector and scalar. Vectors have an effect on direction as well as being measurable and given a direction, whereas scalar are simply measurable. So when we look at speed, is it a vector or scalar? Well, it's a vector because speed is in a particular direction. I might be moving to the left, to the right, and so on, but it's also, I can also measure it. Working in the opposite direction, drag is pulling backwards, so it's in a particular direction, and I can also measure it. What about area then, scalar or vector? Well, it's scalar because the area of an object isn't a directional force or quantity, it's simply something that can be measured. Density, similar, is a measurement, so it's scalar, not vector. And then finally weight. Well, weight has gravitational forces acting on it, so that pulls downwards, it's directional. So factors which are directional and can be quantified are vectors, whereas those that can only be quantified and measured are scalar. Finally then, we've got something called resultant force. When two forces oppose each other, if one force is bigger than the other, then the force pushing that is going to push in the direction of that force, and it's going to be what we call the resultant force. So let's have a look at a little diagram. Say, for instance, I have 7 newtons pushing to the right, and then I've got 2 newtons pushing to the left. The force of the 7 newtons is greater than the force of the 2 newtons, so the 7 newtons is going to win. But it doesn't push with the force of 7 newtons. Because it's being opposed by 2 newtons, the resultant force is 5 newtons to the right. I simply deduct the smaller one from the bigger one, and it's the direction of the bigger force. So here's a few factors for you, questions, for you to have a go of. Pause the video, have a think, try and work them out, and then I'll go through the answers. So, which 3 factors are affected by force? Remember, the car was changing, its speed was changing, its direction was changing, and its shape changes, it crumpled up. Which forces are being described? A force that opposes motion when objects rub against each other. Well, that rubbing motion creates friction. A force created by floating, that was the upthrust that forces objects upwards, stopping them from sinking. And a force created by gravity pulling something down, it's weight, or sometimes known as gravitational force, but the weight pulling it down. Which is two-dimensional, having both magnitude and directional. Well, that's the vectors. The scalars only have magnitude, only can be quantified, whereas vectors are in a particular direction, such as speed or drag. Is acceleration vector or scalar? Well, you accelerate in a particular direction and it's got a magnitude, a quantity, so it's a vector. And is weight a vector or a scalar? Well, weight or gravitational forces pull you downwards, and they can be quantified, so it's a vector.